Before. There are only 10 types of people in the world, those who understand binary and those who don't. 1 0 in binary is 2. So if you understand binary, you get the joke. If you don't, you're scratching your head saying he's ludicrous. All right. We're going to be talking about binary number conversion. You'll be tested on this. Yeah, we'll find out in a minute. Binary, remember at the very beginning of the semester, we watched the little Tron video about the little bit, and it's either yes or no. Everything in the computer is based on the power of 2 because it's all based on the yes or no answer, on how computer memory works. There's lots of strange powers of 2 numbers that we see all the time, where we see things like a 128 gigabyte thumb drive. It's like, that's kind of an odd number. Why is it 128? Why isn't it 100 or 150?
Well, because
it's based on a power of 2. Same with all of these different numbers. Usually when you get drives size, nowadays we get a terabyte, but the terabyte really is 1,024 gigabyte, which is really a power of 2. And so this is the most math-intensive part of the class. You just wrote your looping calculator. 2 to the 6th is 64. 2 to the 9th is 512. So when we're converting binary to decimal, we're going to learn how decimal number 2 in binary is 10. And a few of these others. So like 200 is 11001000. We're going to talk about how to do that. Whenever converting binary numbers, you're always, unless you have a fantastic mathematical brain and that you don't need to write anything down, you're going to write down, usually on your paper, powers of 2 from right to left. This is not intuitive. Right to left. So powers of 2. So 2 to the 0. Bad pen. 2 to the 0 is what? Is 1. 2 to the 1? 2 to the 2. Second? 8, 16, 32, 64, 128, etc., etc. I'll just kind of stop there. These are all powers of 2. 2 to the 3rd, 2 to the 4th, etc. 2 to the 8th, 4th, 5th, 6th, 7th. 7. Okay. So you're always going to want to write at least these decimal numbers, 128 down. How many you need is dependent on how big of the number is that you're converting. So in this case, we are starting with a binary number, 01101110. So I'm going to need 8 positions. I happen to outline 8 positions from 1 through 128. See how that goes? I take the binary number starting at the right and filling it in from right to left. 0, 1, 1, 0, 1, 1, 0, 1, 1, 0. See how I did that so far? Now it's a matter of adding up the numbers that are above where the 1s are. So I add 64 plus 32 plus 8 plus 4 plus 2. So that's 96, 104, 108, 110. So this is 110. Did I blow your mind?
Yeah, I mean, like, I understand how you got it. I just don't even understand how you added all those numbers in your head.
I've done the binary numbers a few times. So let's do another one. So this next one is still another big one. 101, 0, 0, 1, 1, 0. 64 and 32. That's 96. right? 6 and 9. Plus 4 is 100. Plus 1 is 101.
Okay, but there's a bunch of ones and zeros even after we get the answer.
Yes.
Not always.
You saw how that worked? Let's do the next one. 0, 1, 0, 0, 1, 1, 1. Doesn't matter. This is 0. 64, 32, 16, and 2. So it's 96. So 96 and 16. 9, 10, 11. Plus 2 is 114. 114. Making sense a little bit? These are a little bit larger numbers. Okay, one more. 0, 0, 1, 0, 0, 1, 1, 0. So these two are 96. We've already established that, plus 4. This is 100. Yes, sir?
Why are you going right to left?
Because this is how binary numbers work. If you want to go left to right and transpose everything in your brain, you're feel free to do so. I don't recommend it. Because they're always going to be written in this way. Okay, does that make sense so far? We're going to go over the things from the worksheet, so don't fret. So now, going the opposite direction, going from a decimal number to a binary number. You start with the same little grid, but now you're going to put ones in the places to total up to 72. So that's too big, 0. That's good. So 72 minus 64 is 8, right? 64 plus 8 is 72. Woot, woot, woot.
Yeah,
That's 8 now. Abby?
When you're converting from decimal to binary, can you get lots of different answers?
Nope. It's always the same answer. And here's why. So this is 8, so that no, yes, no. So 72 in binary is 0, 1, 0, 0, 1, 0, 0, 0. See how I did that? Anon?
Is it always up to like 8 digits? Or?
No, it can go on. Numbers can go much larger than the maximum. This is 255. 255 is the maximum number that 8 bits can represent. We know that we have numbers that are much larger. You've heard of 64-bit computers. You can imagine 64 bits is billions and billions. It's mondo. Okay, so let's go through the next one. The next one's 14. You always start, when you're doing it from decimal to binary, you always start from the left, and you need to have at least one number that is just the same as or just less than your number. So these numbers don't matter all the way up to here because 16 is too big. So I could write zeros out forever in a day, and they're insignificant, so to speak, that they don't matter. So I need an 8, and 4 makes 12, and a 2 makes 14. So in shorthand, I can just do 1, 1, 0, that's 14. I could put zeros off to the left forever if I wanted to. It doesn't matter. They're insignificant. So 32 is really easy. Boop. So 32 is 1 with 5 zeros. You have to do the zeros off to the right because they're significant. They're holding place. Nope. Plus 1 is 31. There's no other way to get 32 here.
Why would you do 30 like that?
Well, you can't. You can add all these up, and that's 31.
Why would you do that? 332. Yeah.
Why make it complicated?
Well, you can't complicate it. You can do it wrong.
There you go.
Yeah, there you
So 7 is real easy. It's a 4, a 2, and a 1. No other way to get 7. You see how that works? Any questions so far? Ethan?
So do you need the 0 in front of instead of 72? Do you need the
No, I put it there just to not shock you too much. But I could have put I could put this and it's still 72 off to the left. Todd?
What if you were converting 0 to binary? How many zeros would you put?
0 to binary is it's still 0, and that's still 0, and that's still 0, and that's still 0, and you could put a whole bunch. Usually there'll be some precedent that the place you're storing things. Now, remember in our assignments we had this thing to convert to int32. We take an integer, we take a string, and we say to int32. Well, that 32 is saying we're using a 32-bit integer. So think of this going off for 32 places.
Oh my gosh.
That's roughly 4 billion, I think, is what it comes to.
Roughly 4 billion.
4 billion is a pretty big number.
So you could also do to int64 or to int16, those kinds of things. Is this making sense just a little bit? Okay. No, don't worry about that. All right. I'm going to bring up the worksheet.
That's a big number. It's actually close to 4.3 billion.
4 billion, give or take a few million. Okay, here's the worksheet. First one is a gimme. 0, right? What's this one? Gavin, what's this one? That is 2. Doesn't matter how many zeros I have off to the left, it's still just 2. I'm going to pick off the easy ones. Sean, what's this one?
That one is 3.
It's 3. It's just one more. See how these are going? So this one, which we would say 1000 or 1000, 1000, so that's an 8. See how that worked? So let's get to be, well, this one is just one more bit than the 8, so that's 9. That's an 8 plus a 1. You see how this is kind of coming together? Let's go to this last one. 0, 1, 0, 1, 1, 0, 1. So that is 64. Hey, Taylor. 64 plus 16 plus 8 plus 2. 64, 16, 8, and 2. 64 and 16 is 80. 88 plus 2 is 90. See how that works? You won't be able to use calculators on the test. Gabe.
I'm going to use it now.
Any questions about any of the other ones of these? Do you want me to work on any of the others? Anyone? Anyone? You pretty much have them. It's just a matter of working through it. Should I go to the second half of the worksheet? No one's saying anything? We're going to the second half of the worksheet.
Don, Mr. Brooks, finished the work?
Okay, 0 is 0. 2 we've already did before. 9 we did before. 1 is easy. Let's do 10. The number 10 is an 8 and a 2. Number 17 is a 16, 3 zeros, and a 1. Now, a little pro tip. Anytime you're dealing with an even number, this bit will always be 0. Anytime it's an odd number, this bit will always be 1. So once you've done the conversion, check your work and go, wait a minute, 79 is odd, but I came up with an even binary number. I must have done something wrong. So let's do 79. 79 is 64 plus 8 makes it 72. So 64, 8, 72. Let's see, 64 plus 8 is 72. I need a 4. So 76, 78, 79. So 1, 0, 0, 1, 1, 1, 1. Makes 79. Twelve is 8 and a 4, so that's 1, 1, 0, 0. 23 is 16 plus 4 is 20, plus 2 plus 1, 23. You see how I'm doing that? 16, 0, 1, 1, 1. Anybody need any of the others worked through? Speak now, forever hold your peace, or turn in your worksheet at the end of the class.
Wait, is 0, 1, 0, 1 the same thing as 1, 0, 1, 0?
Nope. So 1, 0, 1, 0 is 10. 0, 1 is 4 plus 1, that's 5. 0, 1, 0, 1 is 4 plus 1 is 5. Right? 0, 1, 0, 1 is 5. 1, 0, 1, 0
Yeah.
is 10.
Would you be able to do the same thing for like base 3? Would you like have just the powers of 3?
You could do that if you'd like to.
It would make it a lot more complicated though than just binary.
It does, and it doesn't compute as far as in the binary world of computing. But yes, there is such a thing as known as octal, which is a base 8. And there's one that's called hexadecimal.
Hexadecimal is
What was that one that's used for like color theory?
Hexadecimal is base 16. Notice these are all based on powers of 2. Hexadecimal, you'll see something like 1A or D7 or something like that. Those are hexadecimal numbers. And for shorthand, programmers will use that. So if you see, you'll see things where you'll see something like 0xFF for different numbers, typically referring to colors and things like that. Okay, last chance for any questions about binary numbers.
That was easy. But like, kind of.
It always starts by doing this little grid, and you might need to add more spaces. Wink, wink, nod, nod on the test. You might need to add more spaces to get to the number you need.
And you're not gonna let me use a calculator?
Not letting you use a